So today we'll be talking about using a CI provider to improve building, testing and distribution of your app. Issue: a lack of CI or having an unstable one means a longer feedback loop. You don't know if your code works and you cooperate slowly with other developers. As you already learned from the previous section, covering your code with test can be very helpful for increasing the overall reliability of your app. However, while testing your product is vital, it is not only the prerequisite on your way to shipping faster and with more confidence. What is equally important is how quickly you detect the potential regression and whether finding them is part of your daily development life cycle. In other words, it all comes down to the feedback loop. For a better context, let's take a look at the early days of the development process. When you are starting out, your focus is on shipping the first iteration as fast as possible. Because of that, you may overlook the importance of the architecture itself. When you are done with the changes, you submit them to the repository, letting other members of your team know what feature is all ready to be reviewed. While this technique can be very useful, it is potentially dangerous on its own, especially as your team grows in size. Before you are ready to accept a PR, you should not only examine the code but also clone it to your environment and test it thoroughly. At the very end of that process, it may turn out that the proposed changes introduced a regression that the original author hasn't spotted. The regression can occur because we all have different configuration, environment, and ways of working. It's harder to onboard new members to your organization. You can't ship and test PRs and different contributions as they happen. If you're testing your changes manually, you're not only increasing the chances of shipping regressions to production, you're also slowing down the overall pace of the development. Thankfully, with the right set of methodologies and a bit of automation, you can overcome this challenge once and for all. This is when continuous integration comes into play. CI is a development practice where proposed changes are checked into the upstream repository several times a day by the development team. Next, they are verified by an automated build, allowing the team to detect changes early. The automated builds are performed by a dedicated cloud-based CI provider that usually integrates from the place where you store your code. Most of the cloud providers available these days support GitHub, which is a Microsoft owned platform for collaborating on projects that use Git as their version control system. CI system pulls the changes in real time and perform a selected set of tests to give you early feedback on your results. This approach introduces a single source of truth for testing and allows developers with different environment to receive convenient and reliable information. Approach introduces a single source of truth for testing and allows developers with different environment to receive convenient and reliable information. Using a CI service, you not only test your code but also build a newer version of the documentation of your project, build your app and distribute it among testers or releases. This technique is called continuous deployment and focuses on the automation of releases. It has been covered in more depth in this section. Using a CI provider such as Circle CI to build your application, run all the required steps and make preview releases if possible. There are a lot of CI provider to choose from, with the most popular being Circle CI, GitHub Actions and Bitrise. For purposes of this section, we have selected Circle CI. It is the default CI provider for React Native and all projects created by its community. In fact, there is an actual project demonstration demonstrating the use of CI with React Native. You can learn more about it here. We will employ it later in this section to present different CI concepts. A rule of thumb is to take advantage of React Native or React Native community projects already using. Going that route, you can ensure that it is possible to make your chosen provider work with React Native and the most common challenge that have been already solved by the core team. As with most CI providers, it is extremely important to study their configuration file before you do anything else. Let's take a look at the sample configuration file for Circle CI taken from the mentioned React Native example. The structure is a standard YAML syntax for text-based configuration file. You may want to learn about its basic before proceeding any further. Note: many CI services such as Circle CI or GitHub Actions are based on Docker container, and the idea of composing different jobs into workflows. You may find many similarity between such services. There are three most important building blocks of a Circle CI configuration: command, jobs, and workflows. A command is nothing more than a shell script. It is executed within the specified environment. Also, it is what performs the actual job in the cloud. It can be anything from the cloud to install your dependencies such as yarn install if you are using yarn, to something more complex like Gradle, WAssemble, debug that builds Android files. A job is a series of commands that describe the steps that is focused on achieving a single defined job. Defined goal jobs can be run in different environment by choosing an appropriate Docker container. For example, you may want to use a Node container if you need to run only your React unit test. As a result, the container will be smaller, having fewer dependencies and will install faster. If you want to build a different a React Native application in the cloud, you may choose a different container, example with Android NDK SDK, or the one that uses OS X to build Apple platform node. To help you choose the container to use when running React Native tests, the team has provided a React Native Android Docker container that includes both Node and Android dependencies needed to perform Android build and test. In order to execute a job, it has to be assigned to a workflow. By default, jobs will be executed parallelly within the workflow, but this can be changed by specifying the requirements for a job. You can also modify the job execution schedule by adding filters. So for instance, a deploy job will only run if the changes in the code refer to the main branch. You can define many workflows for different purposes. Example one for test that would run once a PR is open, and others to deploy the new version of the app. This is what React Native does to automatically release its newer version every once in a while. You get early feedback on added features and swiftly spot the regression. Also, you don't waste the time of other developer on testing the changes that don't work properly configured, and working CI provider can save you a lot of time when shipping a new version of an application. By spotting errors beforehand, you can reduce the effort needed to review the PRs and protect your product from against regression and bugs that may directly decrease your income. Don't be afraid to ship fast with continuous deployment. Establish a continuous deployment setup to ship new features and verify critical bugs faster. Issue building and distributing your apps manually is a complex and time-consuming process. As you have learned in the previous section, automation of the critical pieces of the development lifecycle can help you improve overall development speed and security. The shorter the feedback loop, the faster your team can iterate on the product itself. However, testing and deployment development are only part of the activities that you have to perform when working on a product. Another important step is the deployment, building and distributing the application to production. Most of the time this process is manual. The deployment takes time to set up and is far more complex than running tests in the cloud. For example, on iOS, Xcode configures many settings and certificates automatically. This ensures a better developer experience for someone who's working on a native application. Developers who are used to such an approach often find it challenging to move the development to the cloud and set up such things as certificates manually. The biggest downside of the manual approach is that it takes time and doesn't scale in consequences. Teams that don't invest in the improvements to this process end up releasing their software at a slower pace. Continuous deployment is a strategy in which software is released frequently through a set of automated scripts. It aims at building, testing, and releasing software with greater speed and frequency. This approach helps reduce the cost, time, and risk of delivering changes by allowing for more incremental updates to applications in production. You are not shipping new features and fixes as quickly as you should. Building and distributing your application manually slows down your development processes, regardless of how big your team is. Even in small product teams of around 5 people, automated build pipeline make everyone's work easier and reduces unnecessary communication. This is especially important for remote companies. Continuous deployment also allows you to introduce standards and best practices focused on improving the overall performance of the application. Some of them have been previously discussed in this guide. With all the steps required for the development in a single place, you can ensure that all releases are done the same way and enroll company-wide standards. Establish a continuous deployment setup based on Fastlane that makes the build and generate the changelog shipped to your app instance instantly. When it comes to automating the deployment of mobile application, there are two ways. The first way is to write a set of scripts from scratch by interacting with Xcode and Gradle directly. Unfortunately, there are significant differences between the tooling of Android and iOS, and not many developers have enough experience to handle this automation. On top of that, iOS is much more complicated than Android due to advanced code signing and distribution policies. As we have said before, if you are doing it manually, even Xcode cannot help you. The second way is to use a pre-existing tool to which the developers have handled the majority of use case. Our favorite one is Fastlane, a set of modularity utilities written in Ruby that let you build iOS and Android applications by writing a set of instructions in a configuration file. After you have successfully built your binary, it is time to deploy them to the destination. Again, you can either upload the file to the desired service, example App Store, manually, or use a tool that will take care for you. For the same reason as before, we prefer to use an existing solution, in this case App Center by Microsoft. App Center is a cloud service with tooling for the automation and deployment of your application. Its biggest advantage is that many of the settings can be configured from the graphical interface. It's much easier to set up the App Store and Play Store deployments this way rather than working with upload from the command line. For this purpose of this section, we will use Fastlane and App Center in Circle CI pipelines to fully automate the process of app delivery to the final user. Describing the ins and outs of the setup would make this section too long. That's why we have chosen to refer only the specific documentation. Our goal is to provide you with an overview and not a step-by-step guide, since the final config will be different for each project. Setting up Fastlane. Before going into the details for Android and iOS, you have to make sure Fastlane has been installed and configured on your devices. Next, you have to run the init command within the React Native project. We will run the Fastlane command twice from each native folder. This is because React Native is actually two separate apps at a lower level. As a result, this command will generate setup files in both iOS and Android folder. The main file in each folder would be called Fastlane, and it's where all the lanes will be configured in the Fastlane nomenclature. A lane is just like the overflow, a piece that groups low-level operations that deploy your application. Low-level operations can be performed by calling actions predefined. Fastlane operations that simplify your workflow. We will show you how they function in the next section. Setting up Fastlane on Android. Now that you have successfully set up Fastlane in your projects, you are ready to automate the deployment of our Android application. To do so, you can choose an Android specific action. In this case, Gradle, as name suggests. Gradle is an action that allows you to achieve similar results as with Android. Gradle use standalone. Our lane uses the Gradle action to first clean up the build folder and then assemble the APK with signature based on past params. Should be able to run a lane build by implementing this. Should produce a signed Android APK. Don't forget to set the environment variables to access key store. These are release store password and release key password and have been set in the example presented above. Setting up Fastlane on iOS. With the Android build been automated, you are ready to move to iOS now. As we have discussed earlier, iOS is a bit more complex due to the certificate and provisioning profiles. They were designed by Apple to increase security. Fortunately, Fastlane ships with a few dedicated actions that help us overcome these complexities. You can start with the match action. It helps in managing and distributing iOS certificates and provisioning profiles among your team members. You can read about the idea behind match in the code signing guide concept. Simply put, match takes care of setting up your device in a way that it can successfully build an application that will be validated and accepted by the Apple servers. Before you can move any further, make sure that your init match for your project. It will generate the required certificate and store them in central repositories where your team and other automation tools can fetch them. Another action that you can use apart from match is Gym. Gym is similar to Gradle action in a way that it actually performs the build of your application. To do so, it use previously fetched certificates and sign settings from match. You should be able to run Android lane build by running the same command as for Android. CD iOS Fastlane build. This should produce an iOS application. Now to deploying the binaries. Now that you have automated the build, you are able to automate the last process part of the process, the deployment itself. To do so, you can use App Center. As discussed earlier in this guide, you have to create an account in the App Center apps for Android and in the dashboard and generate access token for each of them. You will be also need a special Fastlane plugin that brings an appropriate action to your toolbar. To so run Fastlane, add underscore plugin App Center. Once you are done with configuring your projects, you are ready to produce with writing the lane that will package the product produced binaries and upload them to the App Center. That's it. Now it's time to deploy the app by executing deploy lane from your local machine, integrating with Circle CI. Using all these commands, you are able to build and distribute the app locally. Now you can configure your CI server so it does the same on every commit to main. To do so, you will use the Circle CI, the provider that we have been using throughout this guide. Now, note: running Fastlane on CI server usually requires some additional setup. Refer to official documentation to better understand the differences between the settings in locals and CI environment. To deploy an application from Circle CI, you can configure a dedicated workflow that will focus on building and deploying the application. It will contain a single job called deploy underscore iOS that will execute our Fastlane command. Pipeline for Android will look quite similar. The main difference would be the executor. Instead of Mac OS on a Docker, React Native Android Docker image should be used. This is simple usage within the Circle CI. In your case, it make it may make more sense to define filters and dependencies on other job to ensure the deploy underscore iOS is run at the right point in time. You can modify or parameterize the presented lines to use them for other kinds of deploys. For instance, for the platform specific app store to learn the details of such advanced use cases, get familiar with the official FastStream documentation benefits. A short feedback loop along with nightly or weekly builds let you verify features faster and ship critical bugs more often. With the automated deployment, you no longer waste your time on manual builds and sending the artifact to test devices or app store. Your stakeholders are able to verify features faster and shorten the feedback loop even further. With regular builds, you will be able to catch or ship fixes to any critical bugs with ease. Ship over the air update when in an emergency. Yeah, we will look into this in the next chapter. Thank you for watching. Bye.